implementation of the test design usually means we will do either go dark on some of the geos and keep all the other geos with the same level of BAU spend as much as possible. And the scale, if it is a scale test, we'll create new campaigns and make sure that scale spend is applied on the selected set of test geos. So that is about implementation. And what we'll go to next is the analysis of geotest results. To start with, we will do a check on how the actually got executed. So how to do this? This table is one way of doing this check. So we will calculate the number of impressions, spend, and clicks that happened during the test period in the anchor cell and in the test cell, and find out the percentage difference between them. So if it, in this example, we are doing a scale test, right? So if you see, the spend has actually increased a lot in the test cell. Like the test cell had almost more than 250% of spend in compared to an anchor cell. So which means the test execution went very well as we planned, and we can go ahead and go into the analysis of our results. If it is a holdout cell, we'll expect that there will be no spend in the test cell during the test period. Okay. In the geotest result analysis phase also, we'll have to do some exploratory data analysis. The first step would be to look at the time series chart, which shows week over week conversions. And we will first mark out our test period. So in this example chart here, the last part of the time series is when the test happened, and I've marked it as you can see. For our lift calculation, we need to actually find out a counterfactual prediction of the conversions for the test cell during the test period, and we will use that as our reference to calculate the lift on. Okay, for this purpose, there are different approaches we use to do to calculate the counterfactual value. One of those methods is difference in difference method, and for that you need to identify a reference period, which is a pre-experiment period that we find to be similar to the test period. So there are two ways of identifying the reference period. One would be the usage of DTW algorithm, dynamic time warping algorithm, which allows us to find the best match to our test period. So we can do that, or we can do a coarse visual match of the test period to another period like this, and use that as our reference. So for that purpose, especially, we need to look at this chart and mark our test and reference periods to see how similar they are visually also. The next chart here is another representation of the geo level time series chart. I've marked out the test period and separately showing the anchor cell and the test cell. What we can hope to see here is that sometimes we'll be able to visually see if there is a lift. So in this example, you see that most of the geos in the anchor cell are actually kind of falling at towards the end of the test period. That is probably a seasonal effect that's happening. But in the test cell, during the test period, a lot of geos are kind of flattening out rather than dropping, just like the anchor geos did. So it's not like absolutely clear, but you can see it a little bit. That is one visual representation of measuring lift. It is actually, I have another chart where you can see this clearly. So you can, I have aggregated them at the cell level. So you have anchor cell and the Facebook scale cell. The orange line, if you see, has been really close. Like the movement of it is really close to the anchor cell until this point where the test happened. And we can see that the anchor cell actually is underperforming compared to the scale cell. this is a really good, like an ideal scenario. We will not always be able to see some lift like this visually, but it's always good to look. What we will be able to see though is that in this kind of individual geo level chart, we can identify some lift happening, if not at the cell level. Right. Now I'll go into the template for calculating our lift. Again, in this template, you need to give some input. So this is your column where you'll mention the test dates, the name of that period that you want to use, and you will also say what is your identified reference period dates. Then we will mention the cell design, so the geo names and the cell name here. Once we do this, we will then go ahead and fill in the latest source of truth data. So this data should include the data points from your test period as well. The columns that I've marked in yellow usually have formula, and you might have to extend them, and it'll automatically populate the cell and periods here. Then we will refresh this pivot table. You will be using this pivot table data points as input for the difference in difference lift calculation and linear regression lift calculation. So we have weekly conversions in the anchor cell and test cell in this pivot table available. The first part of this is actually your reference period, and the rest is your test period. In the difference in difference sheet, we have two placeholders. So for test period, you'll have to copy paste your anchor and test cell conversions at week level in this place. And the same way for the reference period, you will copy paste. So this will be your source for that. Once you do that, automatically we will be seeing the lift percent here. So the concept here is first we will calculate the percentage change that happened in the anchor cell compared to the reference period. And with this percent change, we will calculate the counterfactual values for our test cell during the test period. So how we do this is we assume that when there was when there is no test happening in the test cell, then it would have also moved the same way like the control markets, and we will apply this percent change on the test cell, and then we will estimate what the predicted values will be. And the difference between this counterfactual test conversions and the actual test conversions during the test period will be the lifted conversions. And the lifted conversions divided by the estimated test conversions would be our percent lift. Right, so this is one of the lift calculation methods, and we have the lift here, percent here. The next would be a straightforward linear regression. So you'll copy paste the same way your input data points here, and using linear regression, we will calculate the weekly predicted test cell conversions, and using that, we will have a total test cell conversions in the test period. This is our counterfactual value. The difference between this predicted and the actual test period conversions would be your lifted conversions. And the same way, we'll calculate lift by using the lifted conversions over predicted test cell conversions. And this actually also gives you an R-squared value, which shows how good of a fit it is. In this example, it's actually 99% the R-squared value is, so it's really good fit. The next step would be the third approach, using GeoLift package. For that, we have an R code. Again, I have a detailed walkthrough of this. Oh, okay, I'll open it again. I'll have a detailed walkthrough of the script in the Monday Skills page. Yeah, again, you'll load a few packages. The data will automatically flow from the GeoTestReads template, so you can just use that. we will have to mention the timestamp at which the test date started. So you'll mention that here. Again, one more time, you'll mention the start date and end date in terms of timestamps in this place. And if you do that, you'll have your GeoLift reads. So from the GeoLift package, we're getting a percent lift of 7.7, and the increment, like the lifted conversions, is about 983. It is saying the lift is significant at an 80% confidence level. So that is the third method of calculating lift. We will summarize them all together at this point in a single view like this. So we will mention the test and reference periods. We will mention the observed values, the percent change between the reference and test periods at a cell level. This will be our difference in difference results. So you'll have to refer to this sheet to fill up these values. The same way for regression reads and GeoLift reads. At
Just pause right there. We covered a lot of material. I think the key takeaway here, I think if it's not coming through, is that you want to take multiple reads that you take a completely different approach and see how they land, right? How close or how different they are, because all these statistical methods are pretty finicky. And more often than not, we find that it gives a lot of nonsensical reads. Like GeoLift is notorious for that.
Yeah.
Every so often, it'll give like 5,000% read or something like that. It would be like, that makes no sense. And then when you go look at the underlying what it's trying to do, you find out that it's messed up, and you have to use. That's why we get the difference in difference and linear approaches are very transparent. You always look at the data, and then you can actually not theorize, but actually like understand what's going on. Much harder to do on the GeoLift basis.